Good afternoon. I'm Jeff from a company called SealCo. We're a company that specialises in low slope architectural style roofing, mainly with membrane roofing. Because we work a lot with European and American manufacturers, we do a lot of these warm roof type situations, and it's quite simple for us because our systems allow for that. So it's really relieving to see the New Zealand market coming around to terms with the European style of building, a better way of building things. And of course, being involved with Bob and the team at the Superhome movement is really awesome to be able to work in with some like-minded people. So in a nutshell, Bob has given you a bit of a rundown of what a warm roof is. First of all, with heating and the thermal envelope, well, when you're going to lose most of your heat, you're going to lose it generally out your windows or your roof, because heat basically rises. So whatever doesn't go out the windows and walls is going to go up and out your roof. So the better way you can hold it into your the heat into your structure is obviously by creating a better insulation cover over your roof. Now, also, I mustn't forget also, is that it does work in the opposite direction as well. So if you've got a really hot day, it's going to help protect from the heat coming down through your roof. I don't know if anybody's ever been up in their corrugated iron ceiling when it's been a 30-degree day and you feel like you can fry an egg in there. It's essentially the same thing. It's by keeping the excess heat out of your building as well. So that's what these are designed for. So as Bob explained, the X-Lam is basically a flat timber base and has really given us free range to create the falls and the direction of the flow of the water off the roof that we need to. So it is a very low pitch, but the idea of a low pitch is that you can keep your ceiling heights and the height of your build as high as you possibly can without having to worry about encroaching into recession planes, height planes, and all those sort of things. So we made the slope out of the polystyrene, the EPS polystyrene. It doesn't really show it much on here, but there is actually a slight slope on here. And as you're wandering around in the garage there, you'll see a whole bunch of polystyrene sheets in there. They're actually essentially placed down. If you have a look around here, you'll see this white plastic here, which is the vapor barrier. That's actually been put down on top of the X-Lam first, and then on the top of that we put our sloped boards going in all different directions. So what it does is it allows the water to slope off to the directions of where the outlets are. Now, because we use unfortunately we have to use solvent-based adhesives, but we use a very low VOC adhesive. It means we can't adhere our membranes direct to the polystyrene because basically the adhesive eats it. So we put a different layer in between the two, and this is what's called a polyiso. Polyisocyanote is once again a European American product. It's a blown polyurethane, which is a more R value product per the density of the board. So it's a very high R value for the thickness of the board. And we adhere that to the top of the EPS, and then our membrane is adhered to the top of that. So what it does is that skin there on the polyiso gives us our surface that we need to adhere our membranes to, and then the membrane does all the waterproofing on top. Essentially, in a nutshell, that's it. There's different variations of the polyiso. There's a dense board up there and around the eaves areas and that sort of thing. We've got the main board here around the centre of the roof, and the polystyrene also has an R value in it, which is increasing the overall R value of the roof as well. So generally the R values these days are supposed to meet about 6.6. I'm quite confident we well exceed that. I don't know what the actual overall R value is, but...
So the...
Yeah. That's the beauty of it. We talked about, Bob explained about the thermal bridging before, meaning that the whole roof is fully covered with the insulation. There's no thermal bridging through any framing or screws or steel or anything like that. And then and like I say, that stops the heat from escaping and stops too much heat from entering the structure. And then you've got your membrane waterproofing on top, which gives you your overall skin on the outside and the waterproofing protection.